All right, so we're still looking at writing equations of lines, but now I'm going to look at special situations. Where you may not realize it, but the lines might have some issues, okay? I don't want to tell you what they are until after we've looked at a couple, okay? All right, so let's take a look at number 8, number 9, and number 10. They all kind of go together. These are 3 that are the same type of special situations. All right, so on number 8, we've got 2 points. And on number 9, we know the line goes through 1 point, the point -3, 7, and we're told the line is horizontal. And then on number 10, we know the line goes through the point 2, -8, and we know the line has an undefined slope. All right, so these are all just a little different feeling than the usual one. Number 8 looks like it's a normal one, so we're going to go in and think about it like a normal one. So normally, let's back up and take a quick peek. Remember this one here? Wow, it's way back. Okay, remember the problem where you're given 2 points, like the point -9, 8 and the point -4, -1, and you just find the slope, and then you plug in the slope, and then you plug in for your point. Okay, so we found the slope, we plugged it in, and then we took one of the points. It doesn't really matter which one, you'll get the same end result. So I usually pick one that's the easiest, smallest numbers, not so many positives. So we plugged in the point, and then we just worked it out till we got to the end, okay? Well, we could use that idea, it seems like, right? So that's what we might be thinking. So we'll go and we'll find the slope. So we're going to subtract our y coordinates and then subtract our x coordinates. We're going to make sure the y's are on top. And it was -10 minus -3, so that really becomes -7. And then 6 minus 6 is 0. So we wound up with an undefined slope. Uh-oh. If it's an undefined slope, then it's not a number. And if it's not a number, I can't plug it in to the formula I was planning to use. I was planning to use this formula, but it's undefined, so I don't have a slope that I can plug in there, which means I can't use this formula. That doesn't mean an equation doesn't exist. It just means the slope is undefined. So what you need to do on one like that is think about what's really going on here. So it really helps to take those points and think about how 6, -10 would be somewhere way down here, and 6, -3 would be somewhere like that. So what we're talking about is, let me do that in blue. We're talking about figuring out the equation for that line. So here's your x and your y-axis. Here's those 2 points that you were given. This is what you want the equation for. You want the equation for this line. And it had an undefined slope, so we didn't have really an algebraic way we could do this because you can't plug in, there's no number that you can plug in for m. But now that you look at it, do you notice what's true about every point on this line? Remember that initial exposure to coordinate graphs, and I asked you questions like that? Doesn't every point on that line have an x of 6? See, if this is a line and this point is 6 something, and this point is 6 something, won't all the points have to have a 6? I mean, you can't come in, move this out of the way. You can't come in and have your line go like this and hit that point and then come like that. It wouldn't be a line, would it? So you have to have every point on the line having an x of 6. All right, so that's my equation, x equals 6. This is the equation. So if they asked you for the equation, you would say x equals 6. The slope is undefined, but the answer is write the equation. Okay? All right, so I wanted you to see that because if you have one of those special lines, sometimes you can't use that algebraic technique we had before. And that doesn't work very well on either of these either. Okay? Number 9 and 10, you should think of in that same way. You should think about what it is you're being asked to do. So sketch it. Here would be the point negative 3, 7. Wouldn't it? It'd be right here. If your line is horizontal, isn't it going to be this way? This is horizontal, right? Okay. So you have your y-axis and your x-axis, and you're trying to get one of the special lines. You're trying to get this line that passes through the point negative 3, 7. Well, you could go through an algebraic process. You could say, well, if it's horizontal, it looks like this, and now I can see I can walk along that line, so it has a slope equal to 0. And then you could go in and do the y minus y1 thing if you wanted to, but you'd be spending a lot of time for no reason. But you could do it. You could plug in the y of 7. You could plug in the x of negative 3, plug in the slope of 0, and it would work. You would have that as a backup if you just couldn't figure out what to do. And x minus negative 3 would be x plus 3. You could think about 0 times anything being 0, or you could distribute first and see that. But you see how that whole right side, it's 0. And so your equation would become just y equals 7. All right, so that would be the equation, and that would be correct. I'm just recommending that you think about it and you don't go through all of that, because you're going to need that thought process. If that word had been vertical instead of horizontal, you would have had no choice. There's no algebraic approach. So for all the ones involving like horizontal or vertical lines, just think through it. So if I'm sitting here and I'm needing that line right there, do you see how this point is up at 7 and so are all these others? Aren't all of those points on that line going to have a y of 7? So my answer to this question is y equals 7, and I'm done. Okay. All right, and so you need that on number 10. If you have an undefined slope, you can't plug it in. You can't use this formula because you don't have a number that you can plug in for m. So you can't use that. So instead, you have to reason it out. So you have to think about 2, negative 8 would be somewhere down here, right? And you have an undefined slope, which means you're on a trail that you can't really walk on, right? This kind of trail. And then think about it, really look at it, and notice that every point on that line, you know the point 2, negative 8 is on it. It's right here. But wouldn't all the points on that line have an x of 2 no matter what? So this one would be x equals 2. That would be your answer. That would be the equation. And it's just saying, I've got that vertical line, all the x's are 2. Okay. So those problems, the 8, 9, and 10, those 3 questions, those special situations I was talking about are when you have horizontal or vertical lines. Horizontal or vertical lines. Okay. All right. So let me just summarize. So don't memorize, understand, but let's think about horizontal and vertical and what all goes together. Okay. So for horizontal lines, the slope is 0. For vertical lines, the slope is not defined. Okay. For horizontal lines, the equation of the line will always be y equals some number. For vertical lines, the equation will always be x equals some number. All right, if you were to look at a table of values, all the points on a horizontal line are going to have the same y. So these would all be the same number. Okay, and then with vertical, it's the other way. Oops. It's supposed to be a y right there. All the x's would be the same number. Okay, so with this one, the y's are the same in all points. Here, the x's are the same. Okay, all right, and then one more thing is think about it in terms of an ordered pair. You know how sometimes you have like 2 ordered pairs and you have to write the equation? Okay, these would be the same if it's going to be horizontal. These would be the same if it's going to be vertical. Okay. All right. So think about the slope formula and why that would happen. If you did slope formula using these 2 points, wouldn't the change in the y's be on top and then whatever's here would be on the bottom? Let me put like a dot squiggle. Whatever's there would be on the bottom. Well, that won't work either. I don't want you to think that that's the same. Okay. All right. So you have 2 points where the y's are the same. So that means that right there on top is going to be a 0 is what I'm trying to get at. Right. And with this one, if you tried to do the slope, because the x's are the same, it means your 0 winds up being on the bottom. See that? And division by 0 is undefined. Okay. And so all of this goes together, and all of this are different ways of connecting those ideas. Okay, so 8, 9, and 10 all dealt with how do you handle special situations where you have either a horizontal or a vertical line. You really don't use the formula. You reason it out. Having a graph really helps.